Hi. In today's video, I'm gonna go over some more ML agents and artificial intelligence, and it's gonna be me taking my AI agent to the next level. Before, he would just move across a floor that had holes in it to get to a target, but now I'm also adding in that this orange ML agent can also jump. So sometimes there may be a spot where the target is or it can't reach it, so he'll be able to jump over some holes to get to it maybe. So that's a new ability of the agent, and I have training that I've trained further than before. So here on this agent, whenever you make an agent, an artificial intelligence agent, you have to have the agent be able to collect some observations about the world around it. So for the jumping, to be able to see if there's a hole, if it's moving in a direction, I'm going to cast ray casts out on each side at the same angle as these gizmos are drawn over here. And then to know if the agent is over a hole and is falling down into a hole, I guess I have this one that goes right down the middle. So I have 1, 2, 3, 4, 5 observations there. And then plus to know where the target is, I give it the observation of the target's location, the agent's location, and the direction to the target. So that's in the code. This is what it looks like now with my most trained brain. Come on. So you can see it's using jumping. It could jump over holes to reach a target, and sometimes I think it's double jumping. Whoa, like right there. Where do you go? But it's pretty well trained. It's got an 83% success rate on reaching the target, even if there's holes, without falling in a hole. So this is the way that the training is for my most trained agent. I have uh, a second best trained agent, the training that I did before this one. So let me just switch my scenario prefab to use that. We'll jump right here. Here it's in the results PPO. And I'll show you the way this one performs. So that's one of the good things about you know, artificial intelligence with neural networks. It's like how far you train something, how smart it becomes. You could have more compelling NPCs or, opponents, or less compelling opponents. You see this one doesn't jump as much, and its success rate is down at 40% that it'll reach a target or fall in a hole. So let's just take a look here, and let me press stop, and let me explain to you the difference between the two trainings that happened. This is a tensor board. So the orange is my first training. It had a simpler neural network. So there were less hidden units, there were less layers in it, but it kind of trained pretty fast and got up to here. And unfortunately, I had the max steps set to 500,000. So it kind of stopped there. So I don't know where it would have gone. Then on my next neural network that I trained, I kind of trained it, and I was going to let it go to 100 million, but I kind of stopped it once I saw it peaking, and then it started to kind of ease off and level out. Then I kind of stopped the training myself. This here is a graph that says how long the episodes are, so how long before a success or a fail occurred. Okay, so this is TensorBoard, and the way you start TensorBoard is you would open up well, first you would have to start your training session with mlagents and press play in Unity. And then after you do that, you could go ahead and open up another Anaconda prompt, like so. And then my environment is called mlagent 16. Then you would type TensorBoard log dir, and then give it the folder where the files are to train. Now, of course, this path isn't correct yet for my project, so I'd have to get the path first. Hold on. Here, the assets folder, and here's where my results folder is. So let me just copy that address and use that in the window. So before I type in the command to start TensorBoard, let me change the directory. And that's so I don't have to type the path to the results folder. So now I could type TensorBoard -- logdir, and then mlagents. Oops, you know what? First, I was typing the TensorBoard command, sorry. Right now I'm in the base environment, which isn't my ML16 environment, so I'll have to do a conda command. Conda activate mlagents 16. All right, so now I'm in my mlagent 16 environment. This is where I have the mlagents Python library. Now I could type the command for TensorBoard. board logder and results. And I would type enter, and that would start up TensorFlow. Just wait, you'll see this one line come in where it tells you the URL. Right, so here's the URL. So I would copy that URL, leave this running, and then I'd copy the URL and let the page load, and that's how I'd start TensorFlow running. Okay, so to start mlagents running, so that I could start a training, I would just have to do this. I have to like first remove any kind of brain from the scene, so that it doesn't, so it's not using the brain, so it's going to actually, use the mlagent library. And I would do the same thing with starting up the prompt like this, and I'd have to activate conda activate mlagents 16. I have to activate my whoopsie. Did I spell something wrong? Yeah. Conda conda activate ml agents 16. Okay, so that starts up the environment. Then I could go to the path and clear the screen CLS. Now I could type in the command ml agents learn. And if I want to use the base configuration, then I would just say force. So it would just start a new one. If I wanted to use my own config file, like I wrote one over here, whole jump, then I could say whole jump dot YAML force. And when I press enter, that would start the mlagent library. So whole jump YAML, that's my own configuration. And I'll just go over that real quick. Here is my configuration file that I made. I kind of started off by copying from one of the configuration files that came from the mlagent library that I downloaded. So here's the library I downloaded. And let me just see, where is it? star.yaml. I just copied from one of their files. So you see they have the 3D ball and match and pyramids and all these files. I could just open them up and look at them, and I could copy them. So I did a start from copying the basic one, which is alphabetically right here, basic YAML. I just started from that one. See, so it just had the basic stuff in it. So I started from copying that, and then I just changed the name over here to whole jump, because why did I put whole jump there, and why did I name my file whole jump? I did that because on my agent, the behavior parameters, the behavior name is whole jump. So the name's got to match, okay? And where am I? So from the default here, I set this to 100 million. I think that doesn't have to have that many to train with. I think that from now, I'll just say like, I don't know, 8 million is going to be enough. I mean, the training will stop. I could stop it before then, but I just wanted enough to like go through. Now for hidden units, I added, I put it up to 20, and the number of layers I had it at 1. So what the hidden units are this. Hidden units, if you look at a neural network, you have the inputs and the outputs, okay? So a hidden unit will be like one of these lines over here. So this one has a hidden unit of 4. And num layers is how many hidden units we have. So we have, in this picture here, we have 1, 2, 3 num layers, and the hidden units is 4. Okay, so that's how you could think of these two things. Now, the more nodes that you have in the middle, it's like, theorized, like the more complex the brain is going to be able to calculate things for you, because you have more nodes in the middle, so that, it could think of more things. Like the more complex a brain, the higher level thinking it could do. All right, so that's what those two settings are that I really used a lot, were the hidden units and the num layers. So if something's harder, I could like increase this here. I've played with those. The max steps is how long the training goes on, and how long the training goes on gets you to get to a point where it starts leveling off. Like over here, this probably could have trained longer. Who knows how high it would have gotten, and it would have leveled off with this orange line. Okay, so that's the YAML. That's how you start ML agents. And what else? What else can I do here? What else could I explain? Think. I guess sorry, but just in case you wanted to know what the other things you could put in the YAML are, you could look it up online. Just look up ML agents training config or something like that, and you'll come up to the documentation where you could click what the common trainer configurations are. And here's like all the different things you could put, like max steps. That's the one I use. That's how many steps the training will take until it stops. If you put 0, that means it's supposed to go like infinity. And, here's also where I kind of got the hidden units and num layers. But then there's all the other ones too, where you can look them up. You could use it. You can play around with them because maybe that'll help you get something training that's not training right. But a lot of times it's going to be like, what do you use as observations? And what are the rewards that you put on for the observations? So on this agent, I kind of have a script that I wrote, and I'll show you the way I set up giving rewards. All right, so first off, for this project, since it's using mlagents, I had to, from the package manager, get the mlagents package installed. So I'll just show that. And let's just look at my project packages. So here's where I got the mlagents package in Unity installed, right? And that allows me to use things like Unity mlagents. And that lets my Unity talk to the Python mlagents. So I had to derive my class off of agent, but agent is derived off of monobehavior. So I still have all my functions from a regular script in Unity, but I have extra stuff because agent derives off of monobehavior, and I have all these extra things. So the virtuals, they're things I could override from whatever is typed here in this agent class. So I did override some stuff, but let's go through the script here. Now, when I was showing you a neural network, the inputs of a neural network, okay, that's this side, the inputs, I specify them through the behavior parameters observation, and the outputs for a neural network, okay, the outputs, they are described through the vector action. So if over here you look in my behavior parameters, here's the vector observation. I said there's 14 inputs. And then for the vector action, that's the output, I have 3 outputs. The 3 outputs are movement on the X, movement on the Z, and then the third output is like whether I'm going to jump or not. Okay. So just know that I had to set those up here. And these numbers here for the outputs and the inputs and the outputs, they're going to match up to what I'm giving in the script. Okay. The other setting here about the stacked vectors, that's like a history of observations to give to the neural network at a time. So, since moving from one place to another without going through a hole, I kind of let it, I kind of gave it a big history of steps so I could look back 20 steps to, see what makes sense. All right, so here in the script, I got the move speed and the jump speed. I mean, the move speed and the jump force for, how powerful the jump is, the size of the floor that you saw was getting made, and then I need to know what the prefab for the floor is so I could put them down and make those floors with the holes in them. And then how many holes do I want on the floor? It's a percentage thing. So I left that in the public variable so it could show in the inspector. Then within the script, I just needed to know what the bounds of the floor were so I could place them side by side like a tile. I needed to know what the target was. I keep track of whether I'm on the ground or off the ground so I can only jump from the ground. No double jumping for me. I have the rigid body, so I could do the jump by adding a force. And then I have the left, right, back, forward, down. Those are basically the results from the ray casts that I'm going to do in the script to see if these rays hit anything and what they hit. So here in the initialize, I get my variables assigned, and then I make the floor. Okay, so when I make the floor, it's just going to first delete all the floor pieces. They're basically prefabs that I instantiate. Floor prefabs that I instantiate. And so first I delete all the floor tiles. Then just to make sure the floor tiles are placed wherever my scenario prefab is in the scene, because remember here, if you look there, I made a copy of this scenario prefab and I stretched it across the floor so the training could go faster. I made 15 of them, So these are the floor tiles. That's the agent, that's the target. So I get an offset because here, this is 0, 0, but I need the offset because this prefab scenario starts over here, this prefab scenario starts over here. So I just need the offset for the prefab. All right, the agent is on a prefab. Then here, if I randomly place the agent or the target, I just have a flag for that. Because as I'm placing floor tiles, I'll decide if I want to randomly place an agent on that tile or a target on that tile. All right, so I just loop through, I make the floor, right? So then after that, the first thing that'll happen if I'm in training is that an episode will begin. So on the beginning of the episode, I make a floor. Okay, cool. Then as the episode is going on, I'm going to collect observations, okay, to send to the mlagent neural network library running in Python. So the observations, I got to use the override of the collect observations method. So this is me manually sending the observations through the vector sensor object. So I just have the sensor object. I just have to just add an observation, add values for whatever I want to add an observation of. So these are booleans. These are the raycasts, whether they hit something or not, for up, down, left, right, forward, backward. So each one of these booleans, that's one value. Then over here, I send the position of the agent. That's a vector 3. That's 3 values. Then I send the direction of the agent to the target, kind of like to try to give the neural network an idea of which way it has to go. So that's the, I just normalized the subtraction of 2 vectors for a direction, and that's 3. And then finally, the position of the target, that's another 3. That's a total of 14. Okay? So those observations get sent, and then the neural network will kind of process it in its own way. Then over here, I have a decision requester component that I put on. So I request a decision every 10. The higher this number is, the smoother the motion should be of my agent. The less times it's going to make a decision. So if it decided to move forward, it's going to move forward 10 times until it changes its mind and does something else. So the decision requester will ask the neural network, hey, or the brain, what do I do now? And then it will get an action received. So on action received, and the action, this is the output of the neural network, the vector action. So however big my vector action was, that's how big this array is going to be. So here I just take the first 2 floats and I use them to decide which way to move. And then the third float, I just take it as like a flag. If it has a value, I'm going to jump. If it doesn't have a value, I'm not going to jump. But then I don't jump if I'm not on the floor, so I don't have any double jumping. And the jump is I just add force up, and I just have a little bit of the value from vector action. So maybe if it was a small value or a large value, that's going to be how high it jumps. So I let the neural network kind of control that, times the jump force, and it's a velocity change. And then I got to check every time I'm going to move something to see if I'm off the floor. So the off floor check is right here. And it's just basically the raycasts that I did when I collected the observations. You see, one of them I did was the down raycast that I sent to the neural network. I saved the value in down, and down is basically right here. It's a member variable of my class. So down is still set over here. So if down is false, like nothing below the agent. If down is false and the transform position y is less than 0, so if I go below the floor, and then I fail, I'm going to say I fail, so I'm going to punish the neural network with a negative value, a small negative value, and I'm going to end the episode. So here's one of the things here is very important with neural networks is the reward system. Like when do I add a negative reward, which is a punishment, and when do I add a positive reward, which is a success, something that I want the neural network to do more. So I don't want it to fall through the floor, but it's going to fall through the floor a lot. I don't want that to be the determiner, so I just made it a small value like minus negative 0.01. These values, man, it's up to you what to set. I kind of do for punishments, I do minus 0.01. That's what I've been doing. And then for success, I kind of do a 1. Like when it does the goal of what I actually want it to do, I give the reward of 1. So let's see what happens on next. So I explain on action received, collect observations, make floor, off floor check. Now, how do I know when I reach my goal? It's going to be when I touch the target, right? So I'm going to do that on collision enter. So if I touch the target, then I'm going to add a reward, a whole value of 1, and end the episode. So hopefully that'll get the neural network to keep trying to get to the target. Then over here, there's just me trying to keep track if I'm on the floor or not. So with that, when I touch the floor, I'm on it. When I leave the floor, when I exit the floor, I'm off it. And that's how I keep track of whether I'm on the ground or not. It's easy. And this is just drawing the gizmos that you saw over here in the scene mode. It just draws those gizmos. So I was able to verify that the rays that I was doing in the collect observation were actually, pointing the way I wanted them to. So I took this logic and then I just applied it here to draw rays from the same thing I had over there. And so that's a script, and that's my results. Let me see. Let me put the brain back in here. So it's the second one that's like the more trained brain, and I don't know. So I kind of did it. I don't know what I'm going to do next. If I'm going to do another ML agent one or something else. I mean, the real thing I wanted to do ML agents for was to get a car to drive around a racetrack and make it realistic, where it makes mistakes, it crashes, and has accidents. So that's why I've been like building my way up with all these little tutorials with just a cube and stuff like that, trying to like really understand the library, the ML agent library, to do the artificial intelligence. So who knows what I'll do next, but that's the end of this video. Thanks a lot.
You made it to the end of the video. I'm so proud of you. This is my website. The main thing I want to show you is that for any of these videos that you've seen on YouTube, I have the tutorial section, which has the blue links for the projects and the orange links are the files. Also, you could go over here and play some of the games we made in the game camp.